Alright, assalamu alaikum. So in this video, we will be studying the chapter on polynomials. Now this topic is in O-level additional mathematics and A-level mathematics, A2 mathematics to be more specific. And we'll try to study and complete this chapter in 1 hour. So now there are a number of aspects in this chapter, and we'll try to cover all of them in just 1 hour. Anyway. So the things that we're gonna cover in this chapter is number one, the basic concept of polynomials, basic concept. Then we are going to study how to divide polynomials, and we'll also study about the universal division identity. In fact, the universal division identity is going to come before we start off with division of polynomials. Then we'll study about the remainder and factor theorems. And finally, we are going to study about how to solve cubic equations. And in this part, I'm going to tell you a calculator trick as well. Anyway, so let's get started. The first thing now, what is a polynomial? A polynomial basically is an algebraic expression. It's a special type of algebraic expression. And what's so special about it is that in a polynomial, the powers of the variable are strictly going to be whole numbers. So we can write this down here with us, that in a polynomial, we'll have strictly whole number powers, and this means that we cannot have -1 as a power, we cannot have a fraction as a power. Yes, we can have 0 as a power. That is the constant term in polynomial. So let's write this down. Polynomial it is a special type of algebraic expression in which the powers of the variables are whole numbers. That is, we cannot have negative numbers or fractions as powers. Right, so this means that we can have a polynomial of maybe this kind, x cubed add 3x squared minus 5x plus 1. This is a polynomial. Why? Because all the variables here have whole number powers. 3 is a whole number, 2 is a whole number, x has a power 1, which is a whole number, and here we have a constant term 1. This also has a whole number power for the variable, which is x to the power of 0, and we know that 0 is a whole number. Therefore, this is a polynomial. However, if I have something like x to the power of half plus 1 is equal to 0, then this is not a polynomial. Why? Because we have a fraction here, and we cannot have powers as fractions in a polynomial. So now, how do we name polynomials? Polynomials are named on the basis of something called the degree of a polynomial. And the degree of a polynomial is nothing but the highest power of the variable in a polynomial. So in this polynomial, we can see that x has a lot of powers. We have x to the power of 3 as well. We have 2, we have 1, we have 0. The highest power of x in this polynomial is 3. Therefore, the degree of this polynomial is going to be 3. So we'll write this down. Polynomials are named according to their degrees, and the degree of a polynomial, I'll underline this part, is the highest power of the variable in that polynomial. So now we'll take a number of polynomials with different degrees, and we'll discuss what do we call those polynomials. So the first polynomial that I can take is something very simple as 1 plus 2. Now this is the polynomial. Why? Alright, I just forgot to tell you one thing. The term poly refers to many, and nomial refers to terms. So polynomial is an algebraic expression with many terms, with more than one term, right? It can have just one term as well, which would be a constant polynomial, uh, even though it seems to be a misnomer, but alright, it is a polynomial. So 1 plus 2 is a polynomial with two terms. A polynomial with two terms is called a binomial. A polynomial with three terms is called a trinomial. And beyond that, based on the number of terms, we don't name polynomials. We call all of them polynomials. So if we take this polynomial, let's say, this has 1, 2, 3, 4 terms. So this would be simply a polynomial. I won't call this a tetranomial or anything of that sort. So polynomials can be named according to the degrees and also according to the number of terms. And according to the number of terms, we can have either a constant polynomial, we can have a binomial which has only two terms, we can have trinomials, and beyond three terms, we just refer to them as polynomials. So we have two ways of naming polynomials. Number one, according to the degrees, and this is the method that is used much more and much commonly. And the second method is according to the number of their terms, which is we can have either constant polynomials or binomials or trinomials, and beyond trinomials, we just refer to them very generally as polynomials. Binomial is particularly important because in your curriculum you will also come across something called binomial theorem, which deals with expansion of binomials, that is a polynomial with two terms, when powers are applied to it. For example, I have a binomial a plus b, and this has been given a power of, let's say, 10. So binomial theorem is going to deal with the expansion of such polynomials. So binomial will be of importance. Apart from that, it's the second classification of polynomials is not really important. Anyway, coming to the degree of a polynomial. So we were talking about this 1 plus 2 here. 1 plus 2 is a polynomial with two terms. That means it's a binomial. And it is a polynomial. Why? Because we have x's here which have powers 0. And since 0 is a whole number, this is a polynomial. So that means that this is a polynomial with, I'll change the color, with degree 0. Such a polynomial is called a constant polynomial. Right. So let's take another polynomial now. Maybe we have x plus 3. Here again we have two terms, that means it's a binomial. And the degree of this polynomial is 1. Why? Because this x has a power of 1, and there's an x with this 3 as well with a power of 0. So this is a first degree polynomial. This has a degree 1. And polynomials with degree 1 are referred to as linear polynomials. And why are they called linear? Because if we sketch a graph of any linear polynomial, we are going to get a straight line of any sort. This is also a straight line. If I draw a graph of y is equal to 3, this will also give me a straight line. But for some reason, the name linear comes about with this. Anyway, now, if I have 2 as my degree, maybe x squared plus 3x plus 1, this means this is a second degree polynomial, and these are called quadratic polynomials. Then if we have degree 3, for example, with this polynomial, this will be called a cubic polynomial. If we have degree 4, it will be called a quartic polynomial. And if we have degree 5, it will be called a quintic polynomial. There are names beyond degree 5 as well, but we'll stay until this point only. Anyway, so what we have done so far, we have covered the definition of polynomial. We have covered the fact that poly refers to many and nomial refers to terms. So a polynomial is an algebraic expression comprising multiple terms, which can be just one term as well. And that makes it kind of a misnomer, but anyway. And a polynomial can be classified on the basis of the number of terms, according to which it can be a constant polynomial, a binomial, a trinomial, and beyond trinomials, we refer to them as just polynomials. The second classification of polynomials is based on their degrees, and the degree of a polynomial is the highest power of the variable in that polynomial. And we discussed that if it is a degree 0 polynomial, it's called a constant. For degree 1, it's referred to as a linear polynomial. Degree 2 polynomials are called quadratic polynomials. Degree 3 polynomials are cubic, followed by quartic and quintic polynomials for degrees 4 and 5 respectively. Right, so we are done with the basic concepts of polynomials. Now let's move to the second part of the video, the second part of this lecture, that is division of polynomials. See, we have studied about the addition, subtraction and multiplication of polynomials in O-level mathematics as well. So let's say if I ask you to add x squared plus 3x plus 2 and 2x plus 1. It's simple. Huh? What we'll do is we will add the like terms together, or with subtraction we'll subtract the like terms together. That means addition can take place between the terms of a polynomial sharing the same degree. I hope this is clear. Likewise is for subtraction, as I just said. Multiplication, it's the same story. In fact, it's the same story as O-level mathematics. That means if I have to multiply these two polynomials together, let's say 2x add 1 times x squared add 3x add 2. Every term of the first polynomial will be multiplied to every term of the second polynomial. So these three will be multiplied together and added, followed by multiplication of this 1 by each of the terms. This is multiplication. Now coming to division. But before we start off with division of polynomials, we will first do a very simple arithmetic division and derive a very important result from that arithmetic division. So let's divide maybe 625 by 7. So how will we proceed? 6 can't be divided by 7. So here's a 0. I can write 0 here, and this 2 comes down. However, 62, the whole thing, yes, it can be divided by 7, and we have 8 here. We subtract 56, and we are going to get 56, yes, 6. So we have 5 here. And now what will happen is that we can have 9 here, and this 2 cannot be divided any further. So what are the things that we can see here? Number 1, we can see a number which is actually divided. The thing that is divided is called the dividend. Then we have a number which is dividing this dividend, which is this 7 right here. This is called the divisor. So divisor is something that divides. Dividend is something that gets divided. Now let's talk about the end result of the process of division. the end result of the process of division yields this answer here, and this answer is called the quotient. However, there is something left behind as well. This left behind thing is also an end result of division, right? So this left behind is simply called the remainder. Now this remainder may or may not exist. But since it can exist, we do have to mention the remainder. When remainder doesn't exist, it's 0. Anyway, so these are the 4 components of division, namely dividend, that is something that gets divided, the divisor, that is something that is going to divide the dividend, then we have a quotient, which is the end result, and the other end result, which may or may not exist, is the remainder. Now, what if I have 89 and 2 and 7, and I am told that 7 is the divisor, 89 is the quotient, and 2 is the remainder. And I have been questioned to find the dividend. Now, how can I find the dividend given the divisor, the quotient, and the remainder? The answer is simple. We can see that if I multiply 7 by 29 and then add this 2 here, I am gonna get the dividend. This brings us to something called the universal division identity. That means for any division sum in the world, be it an arithmetic division, be it a division of polynomials or whatever, these 4 things are gonna exist in any in any division sum, and we can sum this up as dividend is obtained when we multiply the divisor and the quotient, followed by adding the remainder. So this is the universal division identity. Universal division identity. Having said that, let's move forward towards division of polynomials. Now, since this universal division identity is a universal identity, that means it holds true for polynomials as much as it does for numbers. This means that these 4 components are going to exist when we divide one polynomial by the other as well. And there are 2 ways basically of dividing a polynomial by another polynomial. The first method is very similar to this method that we have done. This method is basically called the long division, right? So we also have a long division for polynomials. So 2 polynomials can be divided by each other using number 1, long division, and number 2, algebraic identities. Right, so we'll discuss the second method first and then we'll come to long division. Now this is the first thing about division of polynomials. The second very important thing about division of polynomials is that division of polynomials is possible only and only when the degree of the dividend is greater than the degree of the divisor. I'll just elaborate on this. So division is possible only when degree of the dividend is greater than the degree of the divisor. I hope this is clear. Alright, this means that if I have a quadratic polynomial as my dividend and maybe a cubic divisor, division cannot take place. Why? Because according to the second law, the dividend has to have a higher degree than the divisor. So this division is not possible. Why? Because the dividend is a polynomial of degree 2, whereas the divisor is a polynomial of degree 3. However, if we reverse the situation here, that means if I have a cubic dividend and a quadratic divisor, in that case, yes, we can have uh, division, right? So this is the first thing about. Uh, uh, these are two things about division. Now, we'll try to understand the relationship between the dividend, the divisor, quotient, and the remainder in case of division with polynomials. The first thing, let's say I have a divisor with degree A and I have a dividend with degree B. Now we are assuming that this division is possible. That means that B is greater than A. So at the end of this division, we are gonna get a quotient and we may or may not get a remainder. So if I have a divisor of degree A and a dividend of degree B, then the quotient will be a polynomial of degree B minus A. This is something very important. What do I mean when I say this? See, let's get back to our example where we were dividing a cubic polynomial by a quadratic polynomial. A cubic polynomial is a third degree polynomial, whereas a quadratic polynomial is a second degree polynomial. So according to this rule that I have just written here, the uh, the quotient that I'm going to obtain will have a degree 3 take away 2, that is 1. Let's take another example. Let's say I have a quintic polynomial as my dividend and I am dividing it by a quadratic polynomial again. So what will be the degree of the quotient? A quintic polynomial is a fifth degree polynomial and a quadratic polynomial is a second degree polynomial. So according to this rule, the degree of the quotient would be 5 take away 2, that is 3. So the quotient will be a cubic polynomial. I hope this makes sense. Now let's come to the remainder. Now since remainder is something that may or may not exist, when a remainder does not exist, the divisor is called a factor. I'll come to this later when we'll start with the remainder and factor theorems. Anyway, so for since a remainder may or may not exist, we will not have a very defined degree of the remainder. But yes, there is a short list. The maximum degree of the remainder, its maximum degree is going to be A take away 1. So if I have a divisor of degree A, the maximum degree of the remainder can be A take away 1. So let's talk about this case where we were dividing a quintic polynomial by a quadratic polynomial. Since a quadratic polynomial is a second degree polynomial, the maximum degree of the remainder can be 1, which means that we'll have at max a linear remainder. Now what if I divide a 8th degree polynomial by a 4th degree polynomial? In that case, the degree of the quotient will be a 4th degree polynomial by, because it's obtained by 8 minus 4. And the maximum degree of the remainder is going to be 3. Why? Because the maximum degree of a polynomial is a minus 1, where a is the uh, where a is the degree of the divisor. Having said all this, let's see how we can divide two polynomials using algebraic identities. Now, when we'll use algebraic identities to divide two polynomials, we are gonna have two things. Number one, we'll have the dividend. Number two, we will have the divisor. Now, what we'll do is, we are gonna make general expressions for quotient and remainder based on these rules that we have studied. What we'll do is, we'll make general expressions for quotient and remainder based on these rules, and then we will apply the universal division identity, which is right here. Dividend is equal to divisor times quotient and remainder. So apply universal division identity. We will carry out some multiplication and addition, and the third step would be comparing coefficients. Right, so let's do an example here. So let's say I have a polynomial 3x to the power of 4 add 6x cube minus 2x square add x minus 3, and I have to divide this whole polynomial by x square plus 2x minus 1. So we can see here that we have a quartic dividend. This is the quartic dividend, and we have a quadratic divisor. So based on the four rules that we studied above, the degree of the quotient would be 2. Why? Because 4 minus 2 is 2. And the maximum degree of the remainder would be 1, because we have a quadratic polynomial. So at max we can get a linear remainder. So a general expression for a quotient can be ax square plus bx plus c. Since we are going to get a second degree polynomial, and this is the general form of any second degree polynomial. And since we are going to get a linear divisor at max, sorry, a linear remainder at max, so we can say that the general expression for this can be rx plus s. This is the remainder. So we have done the first step. That is, we made general expressions for the quotient and the remainder. Now, we are going to apply the universal division identity. What will we do? We'll have the dividend, that is 3x to the power of 4, add 6x cube, take away 2x square, add x, take away 3, which is identical to the divisor times the quotient, and here I'm going to write the general expression of the quotient. Add the remainder, which is rx add s. Now the second step would be to multiply the right hand side here. So we'll get ax to the power of 4, add bx cube, add cx square, add 2ax square, add 2ax cube, add 2bx square, add 2cx, take away ax square, take away bx, take away c, add rx, add s. Now we'll collect the like terms. So we have ax to the power of 4, add x cube, b, and 2a can be put together. b add 2a. Add x squared. Now let's collect all the terms containing squares. So we have c, we have 2b, we have negative a. Now let's collect all the terms containing x. That is 2c here, negative 2b, negative b, and plus r. Now let's get all the constants. And the only constant that we have here is s. Now let's see, have we included all the terms or have we missed something out? So we have 1. Alright, yes, we have actually missed something out, and that is this c here. So we'll just write this here. So we have negative c add s. Now what we are going to do is we will compare the coefficients. 3x to the power of 4 add 6x cubed, take away 2x squared, add x, take away 3. So now if we compare the left side here and the right side here, we will see that the coefficient of x to the power of 4 on the left side is 3, whereas on the right side it is a. And since this is identical, it means that a is equal to 3. We will repeat this process for each of the terms. Now let's come to x cubed. So we can see that on the left hand side the coefficient of x cubed is 6, whereas on the right hand side it is b add 2a. This means that 6 is equal to b add 2a. And since a is equal to 3, we can put this here and we'll have 2 times 3, which is 6 again. So here b is equal to 0. Now let's repeat this for the quadratic term, which is this. We can see that for x squared, the coefficient is negative 2. And here it is c add 2b take away a. So these two are going to be equated now. So negative 2 is equal to c add 2b take away a. We know that b is 0, so this whole thing becomes 0. We know that a is 3, so this becomes negative 3. So we have negative 2 is equal to c minus 3. So c becomes 1. Now let's come to the linear term. For x here, the coefficient is 1. So this 1 will be equated to this whole thing right here. So we get, I'll just go down a bit. Right, so we get 2c take away b add r, this whole thing is equal to 1, b is 0, c is 1, so this becomes 2, and r would become negative 1. Now finally let's dig into the constants. The constant here is negative 3, and the constants here are negative c add s. Therefore, negative 3 can be equated to negative c add s. We know that c is equal to 1. So negative 3 is equal to negative 1 add s, which gives me s is equal to negative 2. Now this is not my solution. The solution will be when I put these values obtained in my general expressions. So my quotient would become 3x squared add 0x, since b was 0, so I can totally omit this term, and add 1. This becomes my quotient. And what would be my remainder? The answer is r, which is negative 1. So this is negative x, and s, that is negative 2. So we have covered the first method of dividing one polynomial by the other, that is using algebraic identities. So let's very quickly review this method once again. First thing that we did was we made general expressions for quotient and remainder based on these four rules. That is, the degree of the quotient will be the degree of the dividend take away degree of the divisor. So since here we had a quartic polynomial being divided by a cubic polynomial, the quotient had to be a polynomial with degree 2. So we made a general expression for a polynomial having degree 2. Then, likewise, we made a general expression for the remainder as well, based on the fact that the maximum degree of the remainder is going to be a take away 1, where a is the degree of the divisor. So since we had a quadratic divisor with us, the maximum degree of the remainder had to be 1. So this comes out to be our general equation, that is Rx plus S. You can take any symbol except the ones that you have used here. The reason why I prefer to take R is because R reminds me that alright, I'm talking about the remainder. So now I'm always saying maximum degree. If the remainder doesn't exist, R would come out to be 0, S would come out to be 0, and so on. Right. Now, once we have made the general expressions, we will apply the universal division identity. That is, dividend is identical to the divisor times the quotient add remainder. So, which is exactly what we did here. We put the dividend on one side, then we multiplied the divisor by the general expression of the quotient, and we added the remainder. Now what we do is, we will carry out the multiplication here, and then we will compare the left and right sides, the coefficients of x on the left and right sides, to obtain the values of a, b, c, r, and s. Now based on the kind of polynomials that you have as the dividend and the divisor, you can have more of these unknowns as well, and you can follow exactly the same procedure for any dividend and for any divisor. Anyway, this is the first method of dividing two polynomials by one another. Now let's move to the second method, and that is long division. I guess I will clear the screen now. I'll clear this working. And I'll use this space only. You can always pause the video, you can go back and see how this is done if you still have any confusions, or you can always ask me in the comments. Inshallah, I'll try to be there for you. Right, so now let's talk about long division. First, what we'll do is we will define long division. It seems really awkward to define a process, but uh, what we're going to do is that this actually explains what the crux of long division actually is. So long division is a method of dividing two polynomials by one another. Now here's an important feature. Based on, one polynomial such that in every step of the division, the degree of the dividend reduces by 1. Right. So let's get to this initial sum here. Now we know that when we are doing long division, we have multiple steps. Huh? It's like a ladder with a lot of steps. Here's one step, here's another step, and so on. So likewise, when we'll be dividing two polynomials by one another using this method, we'll be having a lot of steps as well. So when we are dividing two polynomials by one another using long division, what will happen is that in every step, the degree of the dividend is going to reduce by 1. So if we start off with a, let's say, quintic polynomial as our dividend, then regardless of what the divisor is, provided that it's obviously less than 5, it's a polynomial of degree less than 5 or 5. So there's one thing that I forgot to tell you. I missed this out. Division is possible when b is greater than or equal to a. In that case also we can have division, but in no other case. Anyway, let's come back. If we have a quintic polynomial, then regardless of the degree of the divisor, in the first step of the division, after the first step of the division, we will have a quartic polynomial. In the next step, we'll have a cubic polynomial. In the step that follows, we'll have a quadratic polynomial. In the step that follows, we'll have a linear polynomial. That is, if the division doesn't stop. Division can stop before that as well. So anyway, let's solve this same polynomial. Let's do this division sum using long division. So I'll just straighten this line a bit. So we have 3x to the power of 4, add 6x cubed, take away 2x squared, add x, take away 3. And we have to divide this by x squared, add 2x, take away 1. So now, what will happen is that, as I said, that with long division, we are going to decrease the degree by 1 at every step. So since we have a quartic polynomial here, the second step should give me a cubic polynomial. This means that I need to do away with this. And how can I do away with this? That this can be done if I multiply my divisor by 3x squared and then I subtract the resulting thing from this polynomial. So I write 3x squared here and I multiply this 3x squared by this. What will I get? I'll get 3x to the power of 4, add 6x cubed, take away 3x squared, and now I will subtract. Now what happens is that this gets cancelled, this gets cancelled, this becomes plus because here's a minus here, here's a minus here, it becomes plus, and we have x squared. Now interestingly, in this question, the degree of the polynomial reduces not by 1 but by 2. But we'll do another example in which the degree is going to reduce by 1. I'll take care that the degree does reduce by 1. Anyway, so now what happens is I'll just get this x down. Now I don't have any term in x cubed, so I'll just move to this term. Now since I have a quadratic term here, the next step of the long division should reduce it to a linear term. And how can that be done? If I multiply this x cubed by 1, I'm going to get x cubed, add 2x, take away 1. If I subtract, this goes away, this becomes negative x and this becomes negative 1. We have a linear polynomial now, and there is no way we can divide this polynomial further. Why? Because we told you that for division to occur, b must be greater than or equal to a. But now b is this. The degree of this polynomial is 1, whereas the degree of a divisor is 2, so division cannot be carried out any further. So we have this as our quotient and this as our remainder. So from this we conclude a few things. Number one, that the every step of the long division will reduce the polynomial by 1, and the important part of the divisor is going to be the term having the degree, right? So let's do another sum. I'll just remove this. Now let's divide 2x to the power of 5, add 4x cubed minus 5x square, add 6x, add 1. And let's say that we have to divide this by x square, add 2x, take away 1. Let's take the same divisor. Now the first thing that you notice here is that in this polynomial, which is our dividend, we don't have any term in x to the power of 4. There's no x to the power of 4 here. If we do not have any, if we have any missing term, then when we make our long division sum, we have to indicate that missing term. How? In this way. And the remaining part will obviously be written in the same way. And now we have x square, add 2x, take away 1. So now, let's start with the division. I told you that when we are carrying out the division using long division, first thing that will happen is that the division is going to reduce the degree of the dividend by 1 at every step, and this will be done using the highest power of the polynomial, that is the divisor of the divisor. So firstly, we have to get away with this 2x to the power of 5. This can be done by multiplying x squared by 2x cubed. Now, I'll multiply this 2x cubed by the whole of the divisor, and this is going to give me 2x to the power of 5, add 4x to the power of 4, take away 2x to the power of 3. Let's subtract. So this becomes 0, this becomes negative 2x to the power of 4, and this becomes plus 6x cubed. Now you will understand why it was important to put this 0x to the power of 4 here, because we are gonna get a term involving the missing term in the following steps. Let's get this 5x squared down. Right, so now we have to get away with this negative 4x cubed, 4x to the power of 4. This can be done by multiplying the degree of the divisor by negative 4x square. Let's carry out the multiplication. So this gives us negative 4x to the power of 4 minus 8x cubed and plus 4x square. So this gives me 0, this becomes plus, so this is 14x cubed, and this becomes minus 9x square. Let's bring this 6x down. Now, in order to get away with this 14x cubed, I have to multiply the degree of the divisor by 14x. So now I'll multiply this 14x by the whole of the divisor. This gives me 14x cubed, add 28x square minus 14x, and subtraction gives me 0, take away this is 37, negative 37x square, and here we have plus 20x. Fine. So now we'll try to get away with this, and this can be done by multiplying this x square by 37. Alright, I forgot to bring this one down. Here it comes. So now we have negative 37x square, take away 74x, add 37. Now let's subtract. This becomes 0, this becomes positive 94x, and this becomes negative 36. We cannot divide any further. Why? Because now this has degree 1 and this has degree 2. So division cannot proceed. So 94x take away 36 is my remainder, and here is my quotient. I hope that division involving I hope long division is also clear now. Now let's come to the next part of this chapter. I'm going to clear a lot of stuff now. Yeah. We'll keep this intact. Right. So let's remove the dirt now. Now let's come to the remainder and factor theorems. Remainder and factor theorems. Now the first thing to remember about these theorems is that let's talk about the remainder theorem first, because the factor theorem is basically a small extension of the remainder theorem only. So remainder theorem. The remainder theorem basically is a method of giving you just the remainder when a polynomial is divided by a linear divisor. So we'll write this down. The remainder theorem is a method of finding the remainder when a polynomial is divided by a linear divisor. So this tells us two important limitations of the remainder theorem. Limitation number 1, it only tells the remainder and not the quotient. And number 2, it works only with linear divisors. So if I have a divisor with degree 2 or degree 3, it won't work. So how does this work? Let's say I have a polynomial, maybe x to the power of 3 plus 3x squared minus 5x add 1, and I have to divide this by 2x add 4. Now I want to find the remainder only, let's say. So what I should do is I should use the remainder theorem, because it's a very short method and it will directly give you the remainder. What I'll do is, I'm not telling the theory behind the remainder theorem right now. There is a very small theory. It's very easy to understand. If anyone of you wants to know about it, you can ask me in the comments and I'll explain it there. Right. So the first step that I'm going to do is that I'm going to write this polynomial as a function of x. So I can say that let f of x is equal to x cubed add 3x squared minus 5x add 1. Now I'll come to my divisor. I'm going to equate this to 0. So 2x plus 4 is equal to 0 gives me x is equal to negative 2. Now what I'll do is that I am going to put this negative 2 in this function here, which means that I will put negative 2 everywhere I have x. So I can say that when x is equal to negative 2, f of negative 2 is equal to negative 2 cubed, add 3 times negative 2 squared, minus 5 times negative 2, add 1. This gives me negative 8 plus 12 plus 10 plus 1, which is 23. 23 take away 8. And the answer is 15. Now this 15 is the remainder. This is the remainder. So I hope the remainder theorem is very clear. What do we do is, we have a dividend. We will write the dividend as a function like I did here. Then we go to our linear divisor and we equate it to 0 and we find the value of x like I did here. Then what I'll do is that I'll put that value of x in the function like I did here. This is going to give me one constant term, and that will be the remainder if two of these are divided together. If any one of you wants to verify your answer, you can use either the algebraic identities method or the long division method to find the remainder. Fine. So this was the remainder theorem. Very simple stuff. Factor theorem is even simpler. Remember, I have been telling all this time that the remainder may or may not exist. If the remainder does not exist, it means that the divisor completely divides the dividend, leaving absolutely nothing behind. For example, if I divide 6 by 3, I get 2 with absolutely no remainder. When the divisor completely divides a particular dividend, then that divisor is said to be a factor of that dividend. So let's write down what a factor is first. So when a divisor completely divides a dividend, it is said to be a factor of that dividend. This means that for any factor, this means that remainder is 0. So putting this in context of the remainder theorem, if I have a polynomial f of x and I am dividing it by a linear polynomial g of x, if g of x is a factor of f of x, this is represented in this way. If g of x completely divides f of x, then remainder would be 0. Let's try to understand it this way. I'll give an example. Maybe I have a polynomial x cubed add bx squared minus 3x plus 5. I have this polynomial and I have been told that it has a factor 3x plus 9. This is a factor, right? We have been told about this. And the question says find b. So what I'll do is that firstly I'm gonna write this as a function. So f of x is equal to x cubed add bx squared minus 3x add 5. Now again we'll come back to our divisor. So 3x add 9 is equal to 0, x is equal to negative 3. Now I'm gonna put f of negative 3 here. So we have negative 3 cubed add b times negative 3 squared minus 3 times negative 3 add 5. So this is negative 27 plus 9b plus 9 plus 5. Fine, so this is negative 27, add 9, add 5, which is negative 13. So we have f of negative 3 is equal to negative 13, add 9b. Now since 3x plus 9 was a factor, the value of f of negative 3 should be 0. Why? Let's go back to the remainder theorem. F of negative 2 in this case gave us 15, and we said that this is the remainder. So this means that the value of f of negative 2 is actually 15, and this was the remainder. Now if it was a factor, the remainder would have been 0, which means that f of negative 2 would have been 0 if it was a factor, which obviously it's not. Now let's come here. Since 3x plus 9 is a factor, f of negative 3 should be 0. This means negative 13 add 9b should be equal to 0. This gives me the value of b as 13 upon 9. So that's it. That's the factor theorem. The factor theorem is the same thing as the remainder theorem, except that the remainder in this case is always known to us, and that is 0. Having studied the remainder and factor theorems and dividing polynomials by one another, we are now ready to take on the last thing in this chapter, and which is solutions of cubic equations. I'll clear the screen and we will move to division of cubic equations. So what is a cubic equation firstly? A cubic equation is a polynomial equation of degree 3, and what happens is that since it's a okay, let's start. So let's say I have an equation which is x cubed, take away 4x square, add x, add 6 is equal to 0. Now one thing that we need to understand is that when we had linear equations, that is something like 2x plus 4 is equal to 0, we got one solution. In quadratic equations, we had either no solutions in this case, or we had one solution in this case, or we had two solutions in this case. In cubic equations, we can have a maximum of 3 solutions and a minimum of 1 solution. That's the interesting part. In cubic, it was possible not to have a single solution, but in quadratic, it was possible not to have a single solution, but in cubic, we will definitely have one solution. And how will we go about it? The possible cases are this, or this, or this. So this is a case where we have one solution, a case where we have two solutions, and a case where we have three solutions. Right. Now the cubic equations that we are going to deal with, they are going to have at least one integer root. The solution of any equation is called the root of that equation. So one thing that I've told you here is that the cubic equations that we are going to deal with in our syllabus, they're going to have at least one integer root. And that is the root that we'll try to find ourselves by trial and error. So now, this trial and error won't be completely blinded, but we are going to get some hint from some place. And that some place is going to be the constant term of the cubic equation in question. Right. So what we'll do is, the first step would be to write this cubic equation as a function. So we'll first say that let f of x is equal to x cubed, take away 4x squared, add x, add 6. Now what we'll try to do is that we are gonna try to get a number such that if we substitute that number in this function, we are gonna get, let's say that number is a, we are gonna get f of a is equal to 0. In other words, this a would be a factor, right? Because we know from factor theorem that f of a is equal to 0, because the remainder in factor theorem is 0. So what we'll do is, we will take our constant term and we will break it into its factors, both positive factors as well as negative factors. So I can get 6 if I multiply 1 and 6, if I multiply 2 and 3, if I multiply negative 1 and negative 6, if I multiply negative 2 and negative 3. So we have 8 possible factors of 6. Now if you notice one thing, you will see that the factors of 6, or for any number for that in that matter, the lowest factor of that number is the negative value of that number, and the highest factor of that number is the positive value of that number. So what we'll do is, I'm now telling a very important calculator trick. Open your calculators and go on the mode section or the menu section if you are using the EX class with series. Go to the menu section and go to the table section. Right. In the table section, you will see f of x is equal to. Type this equation there with x's and all. So I'll type x cubed, take away 4x squared, add x, add 6. Let me enter this on my calculator first. X cubed, take away 4x squared, add x, add 6. Now if you are using the class-based series of calculators, it will also give you an now press is equal to sign. Press is equal to sign. This is going to give you gx. Do not enter anything here and just press is equal to. Now your calculator is going to ask you start and end. In the starting value, write negative 6 and press is equal to. Then in the ending value, write down 6 and press is equal to. Okay, negative 6. The ending is negative 6. Alright. Now you are going to get a table in which you have one column as x and the other column as f of x. Now we'll take a look at f of x and see where f of x is equal to 0. And here you can see that there are actually 3 values of x where f of x is equal to 0. We'll just take the first one. The first 0 occurs at negative 1, right? So now what we will do is, we will say, now this is some working that you have done on your calculator. This is not anything that you will show on your examination. This is just calculator stuff. Now what you will say is, when x is equal to negative 1, f of negative 1 is equal to, you will show the first substitution. And we know that this is going to give us 0. So this means that x plus 1 is a factor of f of x, where f of x is this whole polynomial. F of x is this whole polynomial, and here we have x plus 1. Let's go back to remainder and factor theorems. What we did was that we wrote our polynomial as a function, then we went to the divisor and we equated the divisor to 0. So if I divide this polynomial f of x by x plus 1 and I want to find the remainder only, this is what I have to do, and this is going to give me x is equal to -1, which will be put in this. So this is actually a reverse process of the remainder and factor theorems. Now I have found x plus 1, which is the factor of f of x. Now, since f of x is a since x plus 1 is a factor of f of x, it means that if I divide f of x by x plus 1, I am gonna get no remainder, and the divisor, and the quotient would be a polynomial with degree 2. This means if I apply my universal division identity, I get x cubed, take away 4x square, add x, add 6 is equal to x plus 1 times ax square, add bx, add c. Now what I'll do is that I am going to try to find a, b and c. I can use either long division or I can use the algebraic identities method. I'll use the long division method. So I have x cubed, take away 4x square, add x, add 6, divided by x plus 1. So first we have to get rid of this x cubed. This can be done by multiplying this x with x square, and then multiplying this x square by the whole of the divisor. So we have x cubed, add x, let's subtract, add x squared, let's subtract, here we have 0, here we have -5x squared. Let's bring down this x. Now we have to get rid of this -5x squared. This can be done by multiplying this x by -5x. This gives me -5x squared minus 5x. Right. So this becomes 0 and this becomes plus 6x. Let's get this 6 down. Now in order to get rid of this 6, I'll multiply this x by 6. And then I'll multiply this 6 by the whole of the divisor. This gives me 6x, add 6. Let's subtract and we get 0 here. Therefore, this we now get x plus 1 times x squared minus 5x plus 6. Now this whole quadratic thing is called a quadratic factor. Now what I'll try to do is, I will try to factorize this quadratic factor using the method of factorization that we have learned in O-level mathematics. So this becomes x plus 1 times x squared, take away 6x, add x, add 6. X minus 6. Okay, so this is not working out. We will use another thing, no problem. Now this is going to work out. So this becomes x minus 2. Let's take -3 common here. This gives me x minus 2 again. So I have x plus 1, x minus 3 and x minus 2. Now in order to solve this This means that I have now broken this entire thing to this. And the equation that I had to solve was this whole thing is equal to 0. This means that x squared minus 4x cubed plus plus 6 is equal to 0 is actually the same thing as x plus 1, x minus 3, x minus 2 whole is equal to 0. This gives me x is equal to negative 1, 3 and 2. And this is how I can solve my cubic equation. Now remember I told you that a cubic equation can have one solution, two solutions or three solutions. And this depends on the quadratic factor. If the quadratic factor is something that doesn't give any roots, any real roots, let's say I have this as plus 5x. What will happen? I don't know. Let's see. We can try b square minus 4ac. So this becomes 5 square minus 4, 1, 6. Alright, it's working out actually. Let's say I have plus 3x square here. Now we know that if b square minus 4ac is less than 0, a quadratic equation cannot be solved. With this, the coefficient of x square is a, this is b, and this is c. So here we can see that we have 9 minus 24, which is obviously a negative number. So if I have a quadratic factor which gives me a negative value for b square minus 4ac, in that case, that quadratic equation, that quadratic factor can't be simplified any further. It can't be solved. In that case, the only solution would be obtained using this linear factor, that is x plus 1 is equal to 0, and we get x is equal to negative 1. So let's say my factorization is x plus 1 times x square plus 3x plus 6 is equal to 0. So this means x plus 1 is equal to 0 and x square plus 3x plus 6 is equal to 0. This gives me no real roots, and this gives me x is equal to negative 1. So this particular equation has only one solution. Now what if I have something of this sort, x plus 1 times x plus 2 whole square is equal to 0. In this case, I have two solutions. How? X plus 1 is equal to 0, x plus 2 whole square is equal to 0. This gives me x is equal to negative 1. And since this is actually the same repeated factor, it's going to be x is equal to negative 2. In this case, we have two factors. That's all for this whole chapter. If there is any confusion, you can ask me in the comments and I'll get back to you. Till then, Assalamu alaikum.